Hello and welcome to another session in physics. In this session, we will be looking at the topic viscosity. We're looking at the topic viscosity, but for that, let us review the previous lesson. Welcome back. In this lesson, we'll be looking first of all at the meaning of viscosity. I'm sure this may be the first time that you're hearing the word viscosity. So what does it mean when we say viscosity? Well, from the definition we have here, viscosity to do with the internal friction that exists between layers of the molecules of a fluid. Fluids come in two forms. Either we have liquid form or we have the gaseous form. So these are two forms of fluids that we have. Alternatively, we have solids, but solids are not fluids. Solids are the only two kinds of fluids we have are either liquid and gaseous fluids. So viscosity applies only to fluids, namely liquids and gaseous respectively. And for viscosity to work, it means that it must be in motion, they must move. Now imagine that you want to pour out palm oil from a gallon. You want to pour out palm oil from a gallon, and this palm oil has been congealed. It has stayed for so many days without exposure to heat. You will agree with me that this palm oil becomes very thick. It is still a fluid, but the only thing is that the viscosity has now increased. And by viscosity, we mean internal friction between the layers of the molecules of this palm oil. It has increased such that the palm oil finds it difficult to flow out from the rubber. Now think of it such as the diagram we have here, water and syrup. Of course, you know that water has low viscosity because of its ability to pour out easily. Water can pour out easily at any point in time. But things like syrup, oils, either groundnut oil or palm oil, they have high level of viscosity. And because of this high level of viscosity, they cannot easily be poured out. Because of this high level of viscosity, they cannot easily be released from the container in which they stay. So, we can define viscosity of a fluid as the measure of how this fluid is to flow, or how resistant this fluid is to flow. In other words, a liquid that flows very easily is said to have low viscosity, but a liquid that finds it very difficult to flow is said to have high viscosity. The same principle applies to gaseous substances because both of them are. It might interest you to know that viscosity is a vector quantity and it is measured in the units of Pascal seconds. Pascal seconds written as Pascal multiplied by second. Pascal second. Having made that clear, at this point, let's look at what we mean by viscosity and velocity gradient of viscous material. We can define viscosity mathematically as the ratio of shearing stress to velocity gradient. Now this is the symbol for viscosity. This is the symbol written like an N with a del, an N. It's a Greek alphabet and it's used to represent viscosity. It is given by force divided by area of the material times the velocity gradient. And if you're wondering what velocity gradient means, it simply means velocity over the length of the material. So when you're asked to calculate the viscosity of a material, that you have the force ready, you can find the force. Of course, you know force is equal to ma, mass of the body times acceleration of that body, and then you divide it by the product of the area of that body and the velocity gradient. The ratio of this gives you your viscosity. If you're asked how to find your velocity gradient, e.g., you can get it using the ratio of velocity to length. So the velocity of that material which is flowing and the length of that material measured in meters helps to give you your velocity gradient. Also, we have W equal to U plus. What is W? W is the weight of the material, U is the upthrust, and V is the viscous force. So the weight of that material, the weight of the fluid, is gotten by adding the upthrust and the viscous force together. The sum of the upthrust and the viscous force gives us the weight of that fluid. Also, subtract the upthrust and the viscous force from the weight of the body, you get 0. And also, when you want to find V, which is the viscous force, you have to get the difference between the weight of the body and the upthrust, that is W minus U. I'd like you to note at this point that materials or substances, in other words, fluids that have low viscosity are things like water, we have kerosene, we have petrol. These ones are more volatile. They are volatile substances. They dry up easily. So because of that, they have a very low level of viscosity. Their viscosity is very low. We also have ethanol, like alcohol. You would notice that all these substances mentioned, they have one thing in common. They have very high volatility. They dry up easily. If you get a drop of petrol and put it on a chair and then leave it for like 5 seconds and then come back, you would notice that you would not find that drop of petrol there anymore because of its high volatility. It dries up fast. The same with ethanol, with the production of alcohol. Alcohol also dries up easily. Water, the same. And that's why when you wash your clothes, you will be able to spread it, and after some time you come back, it's dried up. I'd like you to do this experiment at your own time. If possible, dip a piece of cloth that you're not using, dip it in water, then get another piece of cloth, or probably the same piece of cloth, and dip it in oil. You can get condensed engine oil, or you can get palm oil. Try to dip it, very small quantity of cloth, into oil and spread both outside. After 9 hours, come back and check the reaction and then write down the observance. One thing you will notice is that the cloth that was soaked in water will dry up faster than that cloth that was soaked in engine oil. Probably the cloth that was soaked in engine oil may not even get dry ever at all, because whenever you touch, always find traces of oil there. That is to show you the difference between substances with low viscosity and high viscosity. Substances with high viscosity take time to dry up, while substances with low viscosity dry up easily. Examples of substances with high viscosity that take time to dry up are things like glue. You're talking about gum. It takes time to dry up. Also, syrup. Some syrups include things like medicines that are used to treat cough. They are syrups as well. And then you talk about grease that mechanics use as lubricants in the tires and wheels of moving vehicles. And then we have glycerin and other kinds of oil as well. Now, I would like to talk at this point about drag force. Drag force is a force that keeps an object continuously moving after the terminal velocity has been attained. When we talk about terminal velocity, we mean the highest possible velocity that a body can attain at any point in time. This drag force is the force that keeps that object continuously moving even after that terminal velocity has been attained. And then we have a man, Stokes, that propagated a theory, Stokes' law. There was something he said with respect to this Stokes' law. He said that at terminal velocity, the upward frictional force F is equal to 6 pi viscosity times RV. Of course, you know what F is. F is the frictional or the drag force. This symbol, like I mentioned earlier, is the viscosity, and R is the radius of sphere or the radius of influence, and dt is the terminal velocity as well. Take time to assimilate this diagram here and see if you for any calculations that have to do with calculating the drag force as it travels through a liquid. At this point, let's look at factors that affect viscosity. When we're talking about factors that affect viscosity, we have about 3 of them. One of them is the property of the material itself, because viscosity varies with material. The property that is used to produce a material affects viscosity of that material. Number 2 is the viscosity of simple liquids, which is affected by temperature and pressure. Viscosity of liquids, which is affected by temperature and pressure. As you can see from the slide here, you will notice that viscosity of liquids reduces when temperature increases. If there is an increase in temperature, it affects the viscosity of simple liquids. It makes the viscosity to reduce. So what it means is like that I gave the instance before. You will notice that palm oil that has been cooled for a very long time becomes congealed. It has high viscosity. It cannot flow out from a container anymore. All you just have to do is increase the temperature, heat the palm oil, and you see the palm oil flowing as well. That is because viscosity reduces or decreases with an increase in temperature. Also, viscosity of liquids increases under very high pressure. So if pressure is high, we say the viscosity increases. So in other words, we can say that viscosity is inversely proportional to temperature. Temperature, I'll use 1/T. Viscosity is inversely proportional to temperature, because the smaller the viscosity, the increase the temperature, it gets even smaller. And alternatively, we can say that viscosity increases with high pressure. So the higher the pressure, the higher the viscosity. So in this instance, we can say that viscosity is directly proportional to pressure. Also, when it comes to gases, we say that the viscosity of gases increases with increasing temperature. The opposite of what happens with the viscosity of liquids is what happens with the viscosity of gases. Interestingly, the viscosity of gases is independent of pressure and density. Now, what are the effects of viscosity? There are about 2 of them. The first one is that viscosity is responsible for different rates of fluid flow. The second one is that viscosity affects the motion of a body in a fluid. The importance or applications of viscosity is that it helps in the making or production of lubricants, and its knowledge is applied in the design of ships and aircraft. And additionally, it is used to estimate how to enlarge the size of particles. And that's all we have for you for today. Thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear soon on your screen.